Good evening, everybody. Thank you for joining in and being part of this evening. On behalf of TCS IN, I, Rahul Soni, delighted to welcome you all to this special masterclass on Introduction to Virtualization. Today, we are diving into the world of virtualization, a core concept that powers modern computing and forms the foundation of cloud technologies. Think about how one physical computer can run multiple operating systems and how companies maximize resources by running several applications on the same server without conflict. That's the magic of virtualization. So in this masterclass, you will learn the fundamentals of virtualization, what it is, how it works, and why it's such a critical skill for aspiring tech professionals. Through real-world examples and live insights, this session will help you to understand how virtualization is used in businesses today, from data centers to cloud platforms, enabling organizations to work faster, smarter, and with greater flexibility. We will also be sharing details about the cloud computing program by TCS IN in collaboration with prestigious IIT Bhubaneswar, a program designed to give you the edge in building future-ready skills and staying aligned with industry needs. And please note, also we have a discount surprise for you. So please stay with us. So whether you are just starting out or brushing up your basics, this session will give you strong foundation in virtualization and help you connect it to the bigger world of cloud and IT infrastructure. So I am thrilled to introduce our expert speaker for today's masterclass, Dr. Debiprasanna Sahoo sir, who is an assistant professor of computer science and engineering in the School of Electrical and Computer Sciences, IIT Bhubaneswar. Before joining IIT Bhubaneswar, Dr. Sahu was an assistant professor at IIT Roorkee. He has also worked with AMD as an MTS design engineer. His research interests are in the areas of performance modeling, formal verification of hardware circuits, ML-assisted simulation methodology, computer architecture, high performance computing, data center architecture, Internet of Things, tiny machine learnings, and micro architecture verification. He completed his PhD from IIT Bhubaneswar, MTech from IIT Madras, BTech from College of Engineering and Technology Bhubaneswar. A very warm welcome, sir.
Thank you. Thank you for the introduction.
Thank you, sir. Before we begin the masterclass, I would like to request to please throw some light on the virtualization and what it is. Why is everyone talking about these days? Over to you, sir.
Yeah, so virtualization is so the topic of today's discussion is virtualization, and virtualization is, you can say, like the heart of cloud computing domain. So like when we study computer science, the main subject that we deal in the computer science course, whole the course curriculum and everything is operating systems, and virtualization is an extension of operating systems into the cloud domain. So it's the component of the, you can otherwise term it as cloud operating system. Okay, so that's the reason why virtualization is the most important concept. And without virtualization, understanding how virtualization works internally until it goes into the complete hardware depth and so on, it is difficult to kind of visualize how exactly the cloud computing system is working. Okay, and unless and understand until we understand how a cloud computing system is working, we cannot develop a very good application for that. Okay, so that's the reason you should be learning virtualization to depth.
Yeah, thank you, sir. Thank you for explaining clearly to the audience. So, without further ado, I think let's explore the fascinating world of cloud infrastructure and virtualization. So, I will hand it over again back to you, sir, for your masterclass.
Thank you, Rahul. I'll start up this topic called as virtualization, and I think already they've given my introduction, so I'll just jump to the topic directly. So what exactly is virtualization? As I was saying that uh, like in computer science, the main thing that we study as which binds everything together, all the topics together, is your operating system course. So like you have the hardware, you have the network, you have the applications, you have all the math running around in the application, everything is there. But the thing that binds everything together is your operating system. Now, operating system is typically told as like a system software. It's a system software which manages the hardware, and it enables running of different application on the hardware, doing memory management, doing process scheduling, and so on. So what happens is virtualization is that it's a process that allows a computer to share its hardware resources with multiple digitally separated environment. Now, what does that mean? Let's look at this particular sentence, break it out into different parts and discuss them together. Uh, it's a process that allows computer to share its hardware. So in a cloud computing environment, we know that we are accessing a remote system. I think last time we discussed about how we access a remote server. Okay. So let's say, for example, we are using something called as google.com. Now, google.com is kind of hosted on multiple servers in the cloud environment or over the internet. Now, it's like that if there are thousands of servers, some servers are running google.com, some servers might be running Gmail. So there'll be some servers which will be running both google.com and Gmail. So like that, whatever websites or whatever applications, so you are also running, let's say, for example, this is Google Slides, right, that I'm using here. So Google Slides is again a kind of a software which is running over the servers in some of these servers. So let's say even there are thousands of servers, some applications will be running on Google Slides. So, Google Slides will be running on some of the servers, and on the same server there'll be Gmail, there'll be google.com, lot of other services are running. Now, the important thing to note here is that two different companies can also run run their own application on the same server. Now, in order to provide such an environment, your server needs to ensure that you are providing a sandboxing environment to two different clients so that they can run their application on the server. Okay. And virtualization is the process which allows the computer to share the given hardware, given server, between two digitally separated environments. So by digitally separated environment, I want to say that they can be two different applications. Like they can be, one can be Gmail, other can be google.com, or the third one can even be amazon.com. So all the three can run on the same environment, on the same hardware. So multiple digitally separated environment are running on the same hardware. And this is allowed by a set of computers. So that means that some set of computers will be enabling you how one particular server is able to run multiple such environment, or a cluster of servers are able to run some kind of environments like this. So this virtualized environment, what it provides allocation of resources. What are resources here? So when we say servers and cloud, we are talking of different resources, like resources like, for example, memory, your main memory of the servers. It can be the processing power of the server, that means the CPUs. It can be the GPUs. It can be the network. It can be storage. So like the disk and other storage elements, right? So all these resources needs to be distributed across different virtualized environment, and this is provided by the virtualization tool. Okay. So what I'm trying to say is, like an operating system is able to do memory management, it is able to do processing, it is able to do CPU scheduling, it is able to do network management, it is able to do storage management. So like that, the virtualization tool or the software or the stack whatever you can say, we'll see what exactly it is. It will allow you to run different set of sandboxed environment or different set of sandbox applications over the cloud. Okay, so you can consider the cloud as one big unit, which will be a cluster of servers and so on, or compute units. And then these compute units will be allowed to be used. So those compute units will contain what? They will contain the memory, because all the servers will have their own memories. They will have their own CPUs. The servers will be connected over a network, and they will be also connected to the internet. And also they will have their own storage devices. Now, what the virtualization tool is going to do is that it will distribute these processing elements, memory, storage, networks, etc., to different applications. So, in a sense, it's going to segregate the environment over this cluster, as well as if two different applications are trying to access the same server, they will be able to access it. Okay. Uh, please, you can ask any question at any point of time if you want. You can just stop me and ask the question. So now, coming back to what are the different types of virtualization? There are mainly 4 different types of virtualization. The first one is server virtualization. The second one is storage virtualization. Third one is network virtualization, and fourth one is data virtualization. Now, first of all, what is server virtualization? Which is where all the technology of virtualization started. Okay, that's server virtualization. The first concept comes here is called as bare metal virtualization. What do you mean by bare metal virtualization? Imagine that there are multiple servers and we need a software that will enable the access to this hardware via access to this hardware. That means that we have different applications which want to access over internet, and this server is there, and 2 different applications now need to access the hardware, and this access has to be provided. This hardware is called as bare metal. You can say that the server is the bare metal, and this bare metal is being given access to different application at different point of time, or even at the same point of time. Similarly, there could be system software virtualization. So bare metal virtualization can be thought of like I'm just giving hardware on rent, and somehow using some software you will be able to access my hardware. And at the same time, I can have system software virtualization where I can say that I can provide the runtime environment. Like for example, you might need a runtime environment which is based on Python. I might need a runtime environment which might be based on Java, or someone else might need a runtime environment which might be based on. It's a huge rain here. Anyways, so someone else might be having a different runtime environment, like they might be developing some kind of a Verilog applications, or something. Different people use the cloud for different purposes. So in order to provide the specific runtime environment, we need system software virtualization. Okay. Now the next category of virtualization, and in the main course that will go in the future, what we will see, I will be covering mostly the server virtualization technique, and some other faculties might be covering network virtualization technique and storage virtualization techniques and so on. Okay. So I'll just give you a glimpse of how server virtualization happens today, and we'll not discuss much about this storage virtualization and not network virtualization, but let me kind of tell you what they are. So first of all, what is storage virtualization? Storage virtualization means that there is a centralized storage pool and it provides scalability. So like for example, there will be a lot of hard drives or SSDs which are connected over a network. Okay, so when you connect one device to the network, we kind of call it as network attached storage. So there is a network in which we are attaching a storage onto the network. That is network attached storage. And this is very common device. This even we use it at our homes. Also, sometimes we use it at our homes, not every time. So this is where you connect a hard drive or an SSD into the network attached storage system and just put it onto the LAN cable, and it just connects to a network. So that way what we are allowing is our hard drive is present over the NAS device, and we are able to access our hard drive from our mobile phones or laptops anywhere sitting and connected to that network. So that's like a centralized storage pool that you connect to the network, and you are able to access it from anywhere. So that's the virtualization that you are getting. Okay, you are sitting anywhere in the network, and you are able to access your hard drive. So that is you provided by NAS. Similarly, what it also provides is storage scalability. What is storage scalability? For example, the other kind of storage virtualization is SAN, where it is a storage attached network. That means that multiple storage devices are connected and a network is formed out of that, and that again that is again connected to the network. So there is a network of storage, and then one of the port is connected to the network. I mean the internet or the internal infrastructure of the cloud and so on. So what this does is that you can plug and play more and more storage devices into this network. So for example, let's say you are, let's say, Amazon.com, and you want to add a lot of new storage elements into your, you want to increase your DB size, let's say database size. So what do you do? So what you will do is you buy another set of bunch of SSDs or hard drives and connect it into NAS, and then again connect it back into the storage network or SAN. So SAN is a network of NAS. That's what you can see. Okay. So now what it provides is scalability. So let's say today you want more storage, you just put them into a NAS and connect it to the network. Tomorrow you don't want it, you can disconnect and put it somewhere else. So that's, but the whole thing, the whole data is now available over the network to you. That is the virtualization that you're getting. Similarly, this also provides some kind of a storage reliability. What do you mean by that? Because they can be replicated. The data which is present in these NASs can be replicated to another NAS, so that if one of the NAS fails, then you can get the data from some other NAS. So this kind of provides storage virtualization. The complete thing provides a storage virtualization. The third kind of virtualization technique is network virtualization. So what is network virtualization? For example, we are having this video call with you, right? So now somehow this I don't know what is this software. This is, I think, WebEx. Okay. So this WebEx tool, what it does, it provides a dedicated bandwidth over the network to you. So this is running, the WebEx software is running over the internet or over the cloud computing systems, or the servers which are deployed to run the WebEx framework, WebEx application. So what it is going to do is it's going to provide a required bandwidth such that your calls do not get disconnected. So even if the overall bandwidth is being used by all the application, some part of the bandwidth in the network will be used for just this purpose. That means the video calling purpose, such that you won't get a glitch in terms of getting any kind of meeting calls or any kind of video lectures or any kind of devices. You don't get buffering. So to meet such kind of requirements, they use something called as software defined networks. So what they do is they kind of prioritize some of the packets which are getting routed over the network, and they are getting delivered to different systems, so such that the quality of services improve. The other kind of network virtualization is your network function virtualization, where several network services are provided as a service, like for example firewall. So firewall, I don't know if you know this, firewall is a kind of a server where, or it's a software which is running on one of the servers, where what it does is it tries to block unwanted traffic. So let's say, for example, you want to block some access to some particular website. So you can configure that via firewall. It saves you from different kind of attack. So it is acting, it's like a security guard who is sitting at the gate of your network and allowing people only if they are eligible to enter. So it allows those data transmission over the network which is allowed for your cloud computing system. So these kind of network, these kind of firewalls are managed using network function virtualization. Similarly, load balancers. For example, you're doing Amazon.com, and let's say there are a lot of requests coming to your Amazon.com website. So what you are going you if you are going to if you are going to send all those traffic to one of the servers, what will happen? It will face some issues after some time. I mean, it will not be able to process all the requests. There will be delay in processing the request. It will be slower, or there might be dropout in terms of processing any kind of request. So now what they do typically is that there are a lot of servers and they put a load balancer at the front. The load balancer is again another server which does the network traffic balancing. So whatever packet comes, it will direct some of the packet, by packet I mean request from the customers. Those requests get directed to specific servers which are running at the backend. So now this is also a kind of network traffic management which is being done by the network function virtualization. Similarly, traffic, they can do some kind of traffic analysis also, like, okay, at this particular point of time in the day, let's say for example 12 to 6 or something, this particular time we are getting maximum number of requests. So we do a lot of analytics in the network using this network function virtualization. Similarly, there is this last category of virtualization, which is recently building up, is because of the big data and this machine learning kind of framework, is the data virtualization, where the storage, retrieval, analysis, and formatting of the data now makes more sense. So how do you provide such kind of storage, data storage virtualization over the network is being provided by this virtualization concept. So I think I will take a break here for Rahul to kind of discuss the other stuff. We will come back to the discussion once we finish that.
So audience, as I promised that we have a surprise for you. So as a part of our commitment to bringing you the best career opportunities, we are proud to present the future of technology with our advanced cloud computing program designed in partnership with the prestigious IIT Bhubaneswar. So this course prepares you for the growing demand in cloud technologies, giving you the skills to manage and deploy cloud-based solutions that powers today's digital world, as Sir has already elaborated about the same. So if I will talk about the program highlights here. So we have a comprehensive cloud learning here. You can see the same on the slides as well. In this program, you will understand cloud concepts, architecture, services, and deployment models like public, private, and hybrid. This course will cover hands-on labs and projects as well. So you will gain practical experience with popular cloud platforms and tools through real world labs. And the lectures and the sessions will be led by directly from IIT Bhubaneswar faculty and industry professionals through interactive online model. And we have flexible learning as well. So we understand that those who are working professionals here, they also join these kind of courses and they are also interested for that. So we have flexibility in learning. So learning will be flexible, combining self-paced study with live doubt clearing and mentoring support. And all the course rated content is prepared uh, keeping in mind that the roles which we have, like cloud engineer, cloud developer, cloud administrator, and with exclusive placement support as well. So you can earn a prestigious certificate from IIT Bhubaneswar after completion of this course. And the top scorers of the program will also get exclusive internship opportunity with IIT Bhubaneswar. And the cost is just 11,499. I think in today's scenario, it's less than your pocket money. So I think to upskill ourselves, we should go for it. So if I talk about who should enroll, okay, so somebody was asking in the chat box, Ritika, Swapnil, so I would like to answer your question. So fresh graduates aiming to build a career in cloud technology, IT professionals looking to upskill in cloud computing, and tech enthusiasts eager to explore cloud infrastructure and services. So this program is your gateway to mastering cloud computing with practical skills, real projects, expert guidance, making you job ready for the fast growing cloud industry. Links has already been posted in the chat box. And if I reveal the discount offer, so we are offering 10% discount, and the last date to apply for this is 30th September. So before 30th September, 12 p.m., if you want to avail this discount, please register for this course. So I would request that don't wait till 30th September or the next week. Today only you can go and directly avail the offer and register for the course. Okay. So I see one question in the chat box as well related to course. How will this program help learners in building their proficiency? Okay, so the course has been meticulously designed for both freshers and individuals, as I already mentioned, pursuing bachelor's or master's degree and working professionals. So with an emphasis on hands-on experience and practical exposure to cutting-edge technologies, cloud computing tools and technologies. So the learner will get access to live lectures, hands-on implementation, assignments, quizzes, industry use cases, and mentorship of renowned industry and IIT Bhubaneswar faculty members. So that's a USP which we are giving you. That's all. I think QR code has been already given in the slides. You might have already taken the snapshots. Please go for it and continue your learning journey. Over to you, Sahu sir.
Okay, I just want to add something to whatever Rahul said. So the complete, uh, apart from what he said that you will be getting an end-to-end this thing. Sometimes what happens is we miss the internal concepts of why a particular thing is working, or why a particular thing we should learn. Okay, and what we try to do at IIT Bhubaneswar is we look at the base always. So we start from very, very fundamental, so that you can build upon it as it goes on. So, for example, some terminologies I might be using now in the course, and you might not be able to understand because they are operating system terminologies. Don't worry about that. Those will be covered as a kind of a basic. There'll be a first lecture will be probably on fundamentals of operating systems. Yes, of course, you might have to go back and see what they are, but definitely we are going to explain those in details when they are in the main lecture. Okay, so let me come back to the technical discussion. Okay, so let's talk about the advantages. When we are saying that we want to do virtualization, let's talk about what are the advantages of virtualization. So the first one is server consolidation. Now, what does that mean? So we want we don't want a lot of machines in our earth, right? So we want less number of servers, but we want to utilize the servers to maximum. What virtualization and cloud computing does is that it reduces the number of physical servers. Of course, when you reduce the number of physical servers, or the space requirement to put them into the cloud computing environment or the data center also reduces. So in a sense, what we are doing is we are reducing the carbon or carbon footprint and all those things by using a centralized repository where you can do the computation. So that's the first benefit. Reduces underutilization of multiple resources running different operating system from different vendors. So let's say you are one of the cloud vendor, user. You are one of the cloud user. Like for example, you are Amazon.com and I am Google.com. And now what we want to do is we want to use the same resources for multiple purpose. So like for example, you might not be utilizing one of the servers to 100%. So let's say your application is more memory bound. That means it spends less time on the CPU, it spends more time on the memory. And at the same time, my application is more CPU bound and less memory bound. So I spend more time on the CPU and use less time on the memory. So what can be done is that, but the difference between you and me is that you want to use a Windows operating system and I want to use a Linux operating system or an Ubuntu based operating system, or you want to use an Ubuntu based operating system but with a different version. I want to use an operating system with a different version. So in a sense, your complete OS environment is different from that of my environment. So server consolidation provides this, or virtualization, hardware virtualization provides this technique where you can co-run both the operating system together onto the same machine, such that you can reuse the underutilized resources. Okay. Similarly, if all the OSs are together in fewer number of hardware platform, it makes it easier for the administrator also to maintain those systems. If there are more than crores of servers, then it will become difficult for the administrators to maintain those servers. So in a small set of servers, if we are able to run multiple applications, that will be better. So that's what server consolidation provides, and server consolidation is provided by virtualization. Similarly, because we are reducing the number of physical servers, it is going to cost you less. The next and the most important thing for an IT industry is your faster deployment. What do you mean by this? So let's say, for example, there are a lot of servers, and what you want is to deploy your application over, let's say, 20 servers or 100 servers. So now what uh, virtualization does is that you create a virtual machine, or in as someone asked, you create a container. If you are using containerization, you create a container or a virtual machine and you just launch it on one of the server, and this whole process can be automated and it can be done in parallel. So if there are multiple servers, you just launch your deployment is the process of running the application on the cloud. So if you want to run your application on the cloud or start your application on the cloud, what you have to do, you have to packet everything and you have to deploy it onto a server. Now this deployment procedure can be done in parallel across several thousands of servers, and virtualization is the technique to which will provide this. Virtualization in combination with this technique called as CI/CD, continuous integration and continuous deployment. So these two techniques are combined together to provide high-speed deployment of your application. This also provides no application downtime. So let's say, for example, there are 1,000 servers which are running your application, and few of them fail. So your load balancer is sitting, right? In the last slide, I talked about the load balancer. Your load balancer is sitting. Now it will quickly figure out that, oh, few of the servers are down because of X reason, because of, let's say, the power is off, or there is a server crash, or the data cache crash, or anything has happened. Because of that, they have failed. Now, because it knows that they have failed, it can redirect your traffic to the other set of servers which are present. So in a sense, your application's downtimes reduces using virtualization technique. Similarly, you can also provide some kind of a test environment. So let's say, for example, I want to deploy my application, and I want my application to go live, but going live is a dangerous thing, right? What if my application has got a bug? So let's say I added some features into the, so that is, let's say an application is already running and I added a feature into it that, okay, you change this part of the application and it will be done. Now, When you deploy it, it goes live again. So that means your code should be perfect when it goes live. Otherwise, what will happen is there will be a failure and your company is going to lose business. So no, but you don't know, you thought that you wrote your code in your local machine and it was working fine, so you just decided to do the deployment. But what if there is a bug there? So, and what if there is a bug there because of the original environment, the runtime environment, the real deployment environment, or the production environment that we can see. So what you can do is you can take some of the servers or subset of the servers which are virtualized over the internet, and you can deploy it onto those server and test your code. So this kind of virtualization also helps in kind of doing testing of your application over the cloud computing environment. Similarly, it provides stability and security. So because you have a virtualized environment, it will be difficult to kind of make an attack, because your software is bounded with your own required operating system. So your own required operating system is providing that security, and the underlying security is provided by the cloud service provider. So in a sense, you will get the complete security and stability that you can run your application on the cloud. Similarly, you get hardware abstraction. So when you do virtualization or containerization, I don't know if you might have used Dockers or any softwares. When you use those software, you might have seen that it is very easy to just take it, run it over the internet, and start using it. What it does, it provides complete hardware abstraction. The virtualization technique underlying which is working enables that any container or virtual machine can be easily run on the servers. Similarly, migration. Let's say you are running some of the virtual machine or virtualized operating system on one of the server, and you decide that, oh, this server is now going for a maintenance, or this server is dying out, or the server is, we have to switch it off for some time because this is consuming a lot of power here. So, and you decide that I want to migrate to another server, I want to move my application to another server. Now, if you would have been doing a normal deployment, then again you have to deploy your application on the other server, redirect your traffic from the first server to the second server, but which is a costly operation. But what virtualization provides is live migration. That means whenever you are even running the application, at the same time you won't, the user of the application won't even have an idea, and the migration of the application from one server to the other server has happened in the backend. So it is so seamless. Like for example, we are right now doing a video communication. We don't even know that probably what might have happened is that this application might have migrated from one server to other server while we are doing this discussion, and we won't feel the glitch. So such kind of techniques are kind of wrapped up in this complete bubble which is called as virtualization. And it also provide backup support, like you at some point of time you want to just take a snapshot of whatever has happened to your application, you want to store, and you can restart from that. This is typically required for people who do a lot of simulations. So people like physics, who work in the physics chemistry domain, they do a lot of simulations, scientific simulations and so on, and they do this simulation over the cloud, let's say. So what happens is, let's say for example they did some simulation, after some time the server failed or something, so they cannot restart their simulation. What they can do is they can start from a snapshot. That means you have different checkpoints that, okay, your application was running, the application was running, at this point this happened to the application, we will keep a snapshot for this application here. So we can restart our application from the same point as it goes on. Okay. So these are some of the advantages of doing virtualization, but with advantages that comes challenges. And the main challenge is the challenge of running multiple operating systems simultaneously. And when we are saying about multiple operating systems, these points comes into these topics comes into our mind. In operating system, we have a concept called as process. Whatever application you run in this system is a process. And there is something called as a CPU context. That means the state of the registers, the state of the pipeline, the CPU pipeline, and the state of the caches, everything is called the CPU context. Now, typically in a normal system, the operating system manages the CPU context. Now, let's say, for example, you are running multiple operating system on the same hardware. Who is going to manage the CPU context? By running multiple operating system on the same hardware, I mean that they are simultaneously executing. We might get a feeling that, oh, I have Windows and Linux on my machine, so I am running multiple operating systems. I'm running multiple operating systems not simultaneously. I'm running multiple operating systems. But the concept that I'm talking about here is that both Windows and Linux are running on the same machine at the same point of time. Now, if that is happening, who is managing the CPU context? So that's the first question. The second question is memory management. There is one memory unit, and typically in normal operating system, paging and segmentation is done using to manage the memory, such that the virtual memory is getting mapped to the physical memory and so on. But in this case, there are two operating systems or more than two operating systems. Who is going to do the paging and who is going to do the segmentation? We cannot allow one OS to do the paging and segmentation and let the other operating system sit idle. That is not possible. So someone has to do it. Okay. Similarly, security. What if one of the OS is actually attacker? It's not a real user, it's an attacker. It's not using your system, but it is just seeing what you are doing. We cannot allow that. So all the OS are expected to run in an unrestricted manner on the hardware, but at the same time we have to provide the security. If you don't allow them to run in an unrestricted manner, what will happen is they will get offended. The operating systems will get offended. Oh, let's say, for example, you are running a Linux operating system as well as in the Windows operating system. Now, the Linux operating system will say, oh, I am owning the hardware. How come the other operating system is owning the hardware also? That cannot happen, because I have some special instructions to execute. I have some privileged instructions to execute, and I am supposed to execute those instructions. Why is the other operating system also executing those instructions? They cannot do that. Okay. So somehow we have to manage the security also. At the same time, there is something called as interrupts. Interrupts, we can say something like, let's say, for example, when I press a key, that is an interrupt. So whatever I type here goes as an interrupt from my IO device into the system. And typically in normal system, the operating system captures this interrupt and sends it to the application which requires the interrupt. So for example, you are using a word processor, we are typing something there. So an interrupt goes from the keyboard into the system and then that interrupt gets forwarded into the word processor and the letter appears on your screen. So that's how it works in the operating system terminology. But what if there are two different operating systems and you press a key? Which operating system it will get delivered to? So those questions come in. Similarly, if the operating system also is wanting to interact with some IO device, network is a kind of an IO device. Your LAN port is also an IO device. So typically in one machine, we have got one LAN port. And in normal operating system, what happens is there is a LAN driver or network driver, which is part of the operating system. And the operating system interacts with the LAN port using the driver. Okay. So now if there are multiple operating systems, LAN port will listen to which operating system? So those questions will come. Similarly, let's say there are, as I was saying, that there are multiple physical servers and multiple operating systems running on those physical servers. Like there are, let's say, two different hardwares and two operating systems are running on these two hardwares. And somehow they want to run the same application. For example, you have a flight booking website, okay? And this flight booking website is actually running on two different hardware. And two different operating systems are running on that. And you have only one ticket left. and you want to buy that. So now what do? So when you submit your request to buy that ticket, it will go to one of the server, and that server will capture the request and process it. Now it has to notify the other server that that ticket is purchased. So in that sense, there will be some communication which will be happening between the two servers. So this will be synchronization between the two servers. And this process is called as distributed synchronization. Okay. So now how do you do distributed synchronization? Similarly, as I told earlier, you might have to record the global state, or you might have to do some kind of backup for your application time to time. Now, what are the challenges of doing all those things, and how do we do it? So that's the solution is provided using virtualization. I will stop here at this point. Why? Because from here on, the basic concept starts. What is a process? How is a process important for guest operating system? How is a process important for our host operating system? What is guest operating system? What is host operating system? All those things will come in, and that will be taught in some of your first lectures. The initial thing that we are going to do in your old curriculum is that we are going to cover the fundamentals from the beginning, and then you will start learning the different applications so that you can understand how is that application interacting with the underlying virtual machine and the containers, and you are able to run different part of it. So I think I will stop here. I'll let uh, Rahul take over.
Yeah. Thank you, sir. Thank you for the insightful masterclass. So I think we have questions as well from the audience. So let's start with the Q&A session. Vasant is asking, can you please throw some light on the serverless computing and how it differs from the traditional cloud computing models?
Yeah, so serverless computing, we just have this terminology, to be frank. Uh, it is like there is another kind of, anyways, there will be some hardware sitting on the other side. Okay. So it is not that that hardware may be a server, that hardware may be a desktop, that hardware can be a mobile device also. Now, if you connect your mobile device and hardware over the internet and you run some software on these devices and you let the other users access this hardware via the network, then it is serverless computing. But the thing is that the more and more you distribute it into multiple devices, the load on the servers goes away. Now, if you consider server and you consider one server, it is a single point of access. But when you consider multiple devices, it is a distributed nature. By the way, so I think last time I told that cloud computing is about learning how computer architecture, operating system, and computer networks interact with each other. Now I'll add something more into it. It's actually these three plus the framework of distributed computing algorithms that make the whole thing work. So basically, the systems aspect is hardware, computer architecture, then operating system, which is going to deal with the system software concept, and the network, which is going to make the cloud computing units interact with each other. Some protocol that bind these three together, but what enables them to work together is the distributed algorithms. So your serverless computing, what it does is it lets all the small devices connect with each other and distribute and talk to each other and do the computation.
Thank you, sir. Thank you for explaining. Anya is asking, is this course caters to only cloud junior developers? So I would like to answer that not only cloud junior developers. We have listed down the potential job roles here, like a cloud junior developer, cloud software engineer, cloud architect, cloud support engineer, and many more. I think, sir, if you want to touch upon the job roles which we have after doing this course.
So okay, let me start from the beginning itself. So what the beginning of the course, what we want to do is we want to give you a fundamental of how a cloud computing environment works itself. Okay, how the hardwares are configured, how the virtual machine runs, what happens internally, and how they are executing your application, how the network is working, how SDN is working, everything theoretically will give a complete background. Okay. Then we'll kind of show you a kind of a demo that how a cloud environment is configured, how to launch your own cloud and so on. Then we will talk about the application side. So someone can go ahead and deploy some application, how to deploy those applications on the cloud, and how to run your application, and what are the different futuristic aspects of cloud. Like for example, there are some talks where they will be talking about how ML will be used inside cloud, which is typically a new thing, to be frank. How do you do analytics inside cloud? So those things are new things inside. So I hope that answers your
Yeah, yeah.
question.
So, sir, with the advent of AI, I think, are there any changes or students or the working professional need to take care of that with the
What do
advent of
you
AI?
see? If you ask me, I feel that the word AI is a hype thing.
Hmm.
To be frank, AI means prediction. AI means prediction, simple. AI, the other name of AI means prediction. Now you can apply prediction. We have been doing in hardware. So for example, I am from hardware background. Inside hardware, we have been doing predictions from 1980s. So we have been doing AI from 1980s. It's nothing new. It's just that now with this budging of that AI is happening, these things are coming up. So what I want to tell from this talk itself is that don't run behind those buzzwords. Go from the fundamental and try to understand the whole basics of what is happening. Then things will come on attach itself easily. I hope that answers your question.
Yeah, thank you, sir. Niti is asking, what are some of the key technologies or tools that cloud professionals should learn to stay competitive in this field?
So, again, I will tell you. So, this is the mindset where we think of what skills we want to acquire, right? I can frame it this the other way, that what skills I want to acquire so that I can get a competitive in the market. You can always learn a skill, but the problem with learning a skill is that what if that skill goes outdated? You'll have to learn another skill. Again, that goes outdated. You'll have to learn another skill. That's what happens with everyone. But if you understand things from fundamentals, that okay, this is the way it works, then if you pull in a new skill, we will tell you a few skills. Okay, if you pull in a new skill, it will be some variant of it. It will be some variant of it. You learn something, then okay, anyways, it cannot be different. We know the fundamentals, it cannot be different. We know the distributed algorithms, it cannot be different than this. So skill is about using some technique where you can just make some changes and your new thing is there. So you have to think in that way, that how do I build my fundamentals such that any new skill comes in tomorrow. ML comes in today, ML is there. Tomorrow, actually, the hardware might change. To be frank, people are running behind ML now. Tomorrow, we are working on hardware. We have a next generation hardware, which is going to come up within 2 years. Yeah, I'm giving you the time, 2 years. The next generation hardware is going to come up. Whatever people are doing now, that will all going to go off. New programming skills will come in. So now, how many skills we will acquire? The main thing is understanding how to deal things with from the fundamental, how to think new algorithms, how to acquire the fundamental concept where if you change a skill, then also I am able to adapt.
So, sir, on behalf of entire team, I would like to extend our heartfelt thanks to
Thanks.
everyone who participated into this webinar, and special thanks to you, Sahu, sir,
Thank you. Thanks
for
a
your
lot.
expertise.
I hope a lot of students join and we'll meet them soon.
So we look forward to staying connected and continuing to learn together.
Sure, sure. Okay.
Please feel free to reach out to us. Lastly, thank you. I, Rahul.
Thank you.
Thanks a lot, everyone. Thank you, sir.